Hi, I'm Skye Marthaler. Welcome to Rooftops of the Solar System. Today, we're entering a new realm, the Kuiper Belt, where we'll visit the king and queen of this domain, Pluto and Charon. But before we start this adventure, take a moment, click that red subscribe button below and the bell icon next to it for all the latest Rooftops of the Solar System and Rooftops of America updates.
Pluto is wild, weird, and wonderful.
Pluto is out there, a cold, distant, little speck of a world. At one time considered the smallest of the major planets, it's now relegated down to the category of dwarf planet, where it reigns as king. What can we say about Pluto besides the controversy about its status? Well, surprisingly, a lot. Humanity got an up-close view of this world in the early 21st century, and it blew open the doors for further scientific inquiry, meaning we now know more about this little world in the Kuiper Belt than many other places that are closer to us in our solar system. But before we get into that, we need to have a conversation about distance. Pluto is not visible to the naked eye. It is incredibly far away, and way too small for us to discern. Those two factors make it difficult even for some telescopes to find. It's at a distance that starts to become a bit difficult for people to comprehend. To provide a bit of perspective on just how far Pluto is away from our Sun, we're going to do a bit of a visual model here. This exercise ball is going to stand in for our Sun, the center of our solar system. And this tennis ball is our Earth. This marble in my right hand, well, that's Pluto. Now, if we were doing this to scale, this would be substantially larger, this would be smaller, and this marble would just be a speck. But this will work for our purposes today. So the Earth is 93 million miles away on average from our Sun, 1 astronomical unit, which puts it right about there. Now, Pluto, we have to go a bit. Would out here, on average, 39 astronomical units away from our star. Pluto is theorized to have formed over 4 billion years ago, the same time the rest of our solar system was taking shape. Unlike its planetary colleagues, though, Pluto's vast distance from the solar center meant it didn't have as much material to work with as, say, the gas giants. While it was able to gravitationally coalesce enough material to form a sphere, it never really gained much in the way of mass. Pluto, unlike Earth or on a larger scale, Jupiter, is not an oblate spheroid. It doesn't bulge in the middle. In fact, its radius at the equator is the same as its poles, 737 miles. It's about half the width of the United States. Overall, it is the 10th largest object we've discovered orbiting our Sun, but only the 16th largest object discovered in our solar system. The hunt for the world that eventually became Pluto began not long after French astronomer Urbain Le Verrier discovered Neptune. There seemed to be something interacting with both the orbits of Uranus and Neptune, and if Neptune's relationship with Uranus was any indicator, that meant another planet even further out there. The search for Planet X, as it became known, occupied more than a few astronomers' hours. But for one astronomer, it became an obsession, and his name was Percival Lowell. Percival Lowell was born in Boston, Massachusetts in 1855 into one of the elite Boston Brahmin families. Ivy League educated and well-heeled, Lowell was a businessman who later traveled and wrote extensively on Asia, particularly Japan and Korea. Lowell may have gotten started in astronomy later in life, but the interest was pretty much already there. He had given a speech about the topic at his commencement from Harvard University as a younger man. His latent interest was uncovered when he read a book about Mars. Even more captivating for him was Schiaparelli's research on canal-like structures on the red planet. Lowell put his substantial wealth to work and built his own observatory in Flagstaff, Arizona in 1893. It was noteworthy for the fact that it was the first time an observatory was planned and built in a remote location with elevation for better viewing conditions. In 1906, Percival Lowell turned his attention to the hunt for Planet X. He began a detailed program to search for this mysterious object. He theorized that this world was 45 times as far away from the sun as Earth and as 7 times as massive as our planet. Later theories would state that this world was black as coal and as dense as iron. In regards to Pluto, Lowell's diligence and methodical approach did set the stage for its eventual discovery. Interestingly enough, the first recorded image of Pluto was actually in 1909, but the small world wasn't recognized for what it really was. It fell to a Midwestern farm boy named Clyde Tombaugh to make the discovery. On February 18, 1930, while working at the Lowell Observatory, Tombaugh, using images captured the previous month, identified a planet-like object with an orbit beyond Neptune. Pluto had been found. Despite being revealed, the object had no name yet. The planet got its name from Venetia Burney, an 11-year-old English schoolgirl. The name had a few things going on in its favor. For starters, it fit into the Roman mythology scheme used in the West, and Pluto, in the Roman pantheon, could turn himself invisible, highlighting Pluto, the world's, being hard to spot. Then, the first 2 letters of Pluto lined up well with the first and last name of Percival Lowell, the P and the L being a fitting tribute to the man who had dedicated so much of his time trying to find this place. In May 1930, the American and Royal Society of Astronomers voted unanimously to approve the name, and this little world now was official. As for those effects on the orbits of Uranus and Neptune, well, those turned out to be an error in the mathematical calculations. Neither of those ice giants are affected by any unknown bodies in our solar system. While Pluto may have little effect on Neptune, the furthest ice giant definitely has an effect on Pluto. You could say it calms Pluto's orbit. At present, the 2 worlds are locked in an orbital resonance of 3:2. Every 3 times Neptune revolves around the Sun, Pluto does 2 orbits. And while their orbits may cross over, there is no chance of them ever colliding. The closest Pluto ever gets to Neptune is still 17 astronomical units. That's 17 times the distance of the Earth from the Sun. Pluto may have been discovered, but it was reticent to give up its secrets, to say the least, because of its incredible distance from Earth and its small size. Very little could be discerned about this world. In fact, for the first 8 decades that we knew it existed, you could have pretty much written everything you knew about Pluto on a single sheet of paper. A few basic things were able to be calculated. It was determined that its revolution around the Sun took 246 years. On a side note, Pluto won't complete its first revolution since its discovery until 2176. A few decades later, Pluto was discovered to have a rudimentary atmosphere. But many of the other features remained a mystery. One of the things that astronomers struggled with in the beginning was trying to figure out just how big Pluto actually was. There were some estimates that had it a bit larger than Mercury, and there were others that had it larger than even Earth. There was a good reason, though, for the variance in these estimates, because Pluto wasn't alone out there. In 1978, at the United States Naval Observatory, astronomer James Christie discovered that Pluto had a companion. Christie called the moon Charon after his wife Charlene, though it just so happened the name lined up perfectly with the ferryman of the dead. Charon wasn't the only moon, though, because Pluto had 4 more: Cerberus, Hydra, Styx, and Nix, all of them being found in the early 21st century, the last in 2012. Even with technological leaps in astronomy, to include the launch of the Hubble Space Telescope, the best view of Pluto at the start of the 21st century was a blurry image. One of the things that created controversy about this world was its size. Pluto may be the 9th largest object by volume, directly orbiting our star, but that doesn't make it very large. Interestingly enough, the conversation about Pluto being a planet or not had actually been going on for some time, but its small size had pretty much been waved away because, as far as anybody knew, it was the only thing out there. The Kuiper belt had been theorized but remained unconfirmed. All that would change, though, when other objects started to be discovered out there. And one of them in particular would bring the controversy to the forefront: the world of Eris. In 2005, a Palomar Observatory team led by astronomer Mike Brown discovered an object more massive but of similar size to Pluto. This trans-Neptunian object was even further out in the Kuiper belt. In many ways, this was the final nail in the coffin for Pluto as a planet. The following year, the International Astronomy Union, or IAU, reached a decision regarding Pluto. This world that had long been considered the 9th planet in our solar system was recategorized, or demoted in the minds of some astronomers, to that of a dwarf planet. It's a decision that remains controversial to this day. In the minds of the IAU, Pluto had failed to clear the criteria set forth that determined, say, a planet from other heavenly bodies in our solar system, like moons or asteroids. Pluto's cardinal sin was it failed to clear out its orbit. Though, despite all this, Pluto seems to have had the last laugh. A few months before Pluto was stripped of its planet title, a space probe barreled out of Earth's atmosphere, going 10.10 miles per second, the fastest man-made object ever launched from Earth at the time. Its destination, what was assumed to be a desolate, cold world of little consequence. The mission was NASA's New Horizons, and it was specifically designed to explore Pluto and the Kuiper belt. At the time, Pluto was the only world of the original 9 planets that had never been visited by humanity. But to get there was going to require remarkable engineering and spaceflight. Getting to Pluto is a challenge. To start with, unlike the 8 major planets, Pluto does not reside in the orbital plane. Its orbit is inclined at 17 degrees. For some perspective, most of the major planets are only a degree or two inclined off the plane. Uranus is the lowest at 0.77 degrees, and Mercury at 7 degrees. Pluto doubles that, and then adds a bit more for good measure. Another point of consideration was just how far Pluto was away from Earth. We've already established the fact that Pluto is very far away. But that doesn't tell you the whole story, because Pluto has a highly elliptical orbit. When it's closest to the Sun, it's only 2.7 billion miles away, which is actually closer than Neptune. But at its farthest, it's 4.5 billion miles away. That's a variance of 1.8 billion miles, the same distance as the Sun to the planet Uranus. It took a decade for the space probe to reach the tiny world, and that was with a gravity assist boost from Jupiter. When New Horizons reached Pluto in 2015, it was more than ready for its moment, and the findings astounded the world. This small, blurry image became a fully realized world filled with amazing sights and mysteries. It's one of the great ironies of Pluto. Here is a world that, in many ways, is more dynamic and intriguing than some of its larger counterparts, which it's no longer considered part of. It can't be emphasized enough the capabilities that New Horizons brought to the table. This was a space probe specifically designed to operate in the cold, dark regions of our solar system. The camera equipment and instrumentation were able to provide a degree of accuracy and clarity that were just unparalleled at the time. New Horizons was only able to do a flyby of the Plutonian system, but what it discovered was significant. Pluto may be tiny, but it packs a mighty punch. The findings of New Horizons changed our entire perspective of the outer reaches of the solar system and cast down long-held assumptions. One of the things New Horizons was able to do was take a closer look at Pluto's neighborhood. It's a bit wild, to say the least. Pluto's smaller moons are all dancing to the tune between Pluto and its largest moon, Charon. Consider Nix, a moon whose orbit is so chaotic it can flip its rotational axis. The standout, though, was Charon. Compared to other moons in our solar system, Charon, when compared to its homeworld, is a veritable giant. By ratio, it's the largest moon in our solar system when compared to its parent body. It's half the diameter of Pluto, though only 1/8 mass-wise, and it's the 6th largest trans-Neptunian object we've yet discovered. Charon's substantial size to Pluto makes this more like a binary world system than, say, a traditional planet and moon one. But whichever body you're standing on, you won't have trouble spotting the other because they're only 12,200 miles apart. To put that in a bit of perspective, that's like flying halfway around the Earth. Charon doesn't orbit around Pluto. They are tidally locked to each other and actually orbit around a point in space, called a barycenter. The closest other major planet in our solar system like this is our home, Earth, but our planet and moon's barycenter still falls in the Earth's crust. Even more interesting is Pluto and Charon are the only planet and moon combo that share a synchronous rotation. Another oddity of this system is, like Uranus and its moons, Pluto and Charon are tipped on their sides. From what has been observed so far, Pluto was at one point, and maybe still is, geologically active. Where this energy is coming from is still open to debate. Based on the structure of its system, there is a theory some of it came from its violent beginning or an early collision with Charon. There is evidence pointing to ancient glaciation, methane dunes formed from winds, and for astropointers, mountains, on both Pluto and Charon. There are going to be some challenges when it comes to astropointing out in this binary system. For starters, it's going to be bitterly cold. Not quite as cold as we saw on the moon Triton, but awfully close. The average temperature on Pluto is negative 387 degrees Fahrenheit. This is a world where nitrogen and methane take the form of ice. In addition to that, it's going to be low light. Even at high noon on Pluto would seem to be like twilight here on Earth, the sun being nothing more than a bright star in the sky. The good news is you'll have long days to take it all in. A day here takes a healthy 153 hours. But you'll notice something peculiar. Like Venus and Uranus, Pluto has a retrograde rotation, meaning the sun will move across the sky opposite than how you'd expect. You'll also be operating in a very low gravity environment, similar to what we found on Triton. Pluto's gravity is about 6% of Earth's, so if you weigh 150 pounds here, you'll be a whopping 9 pounds there. Now, it's time for us to begin our astropointing journey in earnest and get down to the surface, starting with Pluto's gigantic moon Charon. When New Horizons flew by, it was only able to image about 45% of Charon's surface. But even that was enough of a picture to make the journey here more than worthwhile. Charon has turned out to be one of the most intriguing moons in the entire solar system. Unlike our moon, which shares similarities with Earth, Charon and Pluto are actually quite different from each other. The first thing you'll notice on approach of this moon is its gray appearance, with one notable exception. The North Pole, in particular, is a rich, deep red color. These colors are perhaps the clearest expression of its relationship with its parent world. The red color found on parts of Charon's surface actually come from Pluto, or specifically Pluto's atmosphere. Particles escape it and then are funneled down onto Charon's surface, where the sun's ultraviolet light activates the organic matter in those particles, providing the red color we see. You'll also notice its landscape has two rather distinct sections. In the south, you'll find the Vulcan Planum, a more smooth plain. In the north, the Ozterra, a highland section. Splitting the two are ridges and chasms crisscrossing the surface. Then there are the craters, though less than you may expect, giving rise to a theory that perhaps Charon's surface isn't as old as we thought. But most importantly for us astropointers, several mountains have been identified as well. The young surface and dynamic features suggest that Charon may be geologically active, a fascinating thought for a moon this small and distant from our sun or a gas giant. Perhaps the energy for this comes from its relationship to Pluto, the two bodies constantly pulling or pushing each other. It also appears to have more water ice than its neighbor, though water being present, even frozen, shouldn't be much of a surprise anymore, considering what we've already encountered on our journey. Once on the surface, there are a couple of places you'll want to check out. The first place is up in the north, the Mordor Macula. This is the dark red area that dominates the North Pole region. Of particular interest may be the crater on the edge of this feature. Dorothy Crater is the largest impact site on Charon, with a diameter of 162 miles, and a depth around 18,000 feet. In addition to investigating the rim, since this is a complex crater, you may also wish to check out the central peak. From there, you should get a wonderful view of the expansive crater system. It's here in the northern hemisphere where we'll find our next destination, Charon's low point. One of the intriguing features of Charon is its many chasmata, or canyons, and they're easily spotted with just a glance at this moon. They were thought to have been formed when Charon's subsurface ocean froze and the expanding ice cracking the crust, leaving behind the landscape that we see today. There are several chasmata that stand out, Argo Chasma being one of them. This canyon is suspected of being around 430 miles in length and has an estimated depth of 5.5 miles. That's over 29,000 feet. Along the edge of this canyon seem to be cliffs that are comparable to the Verona Rupes we visited on the Uranian moon of Miranda. Argo Chasma isn't the only noteworthy one, though. There's also Serenity and Manjeet Chasmas, both quite noticeable as they slash diagonally across Charon, a dividing line of sorts between the highlands of the north and the plains of the south. To find the low point, though, we need to head to Cayuche Chasma, which is fairly close to the North Pole. This Y-shaped chasm stretches about 250 miles in length, just a bit shorter than the Grand Canyon here on Earth. While it may share a similar length, its depth is a whole other story. This canyon on Charon has an estimated depth of over 8 miles, putting in the running as one of the deepest known features in our entire solar system. Journeying down to these depths will provide a fascinating insight to the interior of this world. Once you get back to the rim, it's going to be time to head south, and you'll travel over the Oz Terra, basically Charon's highlands. This landscape is about a half-mile taller than the plains in the southern hemisphere. As you journey south, you're soon going to encounter the feature that actually separates these two landscapes, Serenity Chasma. Serenity Chasma is one part of a larger belt of cracked terrain running across the equator. This area is thought to have been formed when Charon's subsurface ocean froze. As the ice expanded, it ruptured the crust of the moon. And as you stand at the base of these cliffs, you'll be able to take in the areas where landslides have occurred. Now, it's time we get to the main event. The reason we're on Charon in the first place. Its mountains. Of the ones that have been identified, only 3 have been named so far: Kubrick, Clark, and Butler Mons. And it's that last one, Butler Mons, named after legendary science fiction author Octavia Butler, that we're most interested in. These mountains, though, all share a common feature and have another name, being referred to as mountains with a moat. Butler Mons appears to sit in a moat of sorts, a depression around the base of the mountain, with a depth up to a mile. It's a fascinating structure, one that really hasn't been seen before in our solar system. Once you cross over the moat, you'll need to make your way up to the summit. Standing on top of Butler Mons is going to give you an elevation of 14,250 feet. And you're going to get a fantastic view, particularly of the moat surrounding the mountain. But despite this respectable height, this may not actually be the highest point on Charon. Due to the massive amount of data still being processed from New Horizons, the high point here is actually still in flux. Recently, it's been determined that Charon has mountain ridges ranging in height over 3 miles. That would provide an elevation of over 16,000 feet. There is also the fact that New Horizons was only able to image 45% of Charon, so there may well be a higher peak on the dark side of the moon that was not imaged. Regardless, when you do determine the highest point, you'll get an amazing view of this fascinating moon, and looking up, you'll be able to see our next destination, Pluto. Pluto was revealed to be a very strange place, with New Horizons opening up a box of mysteries that shall puzzle astronomers for decades. Like all great scientific discoveries, it has led to more questions than answers. As for this world, as mentioned before, it has incredibly diverse physical geography. As you approach Pluto, you'll be able to take in this diverse and rugged landscape. In addition to the typical craters, though like Charon less than you may expect, you'll also note that it's a rather colorful world, with variations of dark and light terrain. One of the easiest things to spy is Pluto's heart, shaped like a Valentine's Day heart. This area is some of the brightest on Pluto. Officially known as the Tombaugh Regio, named after Pluto's discoverer, Clyde Tombaugh, this is a perfect spot to make landfall. From here, you're going to be able to check out a variety of fascinating sights that are unique to Pluto, and that's to include its highest point. Our first site is right where we touched down. One of the larger features in the Tombaugh region is Sputnik Planum. It's a massive glacier, so large and heavy that it actually changed Pluto's orientation. But this glacier wouldn't be like any you've encountered before, because the ice making this one up is actually nitrogen. The surface is highly reflective and covered by polygon-like shapes separated by depressions or troughs. Like glaciers here on Earth, it may be treacherous to cross, the nitrogen making for a soft surface that is prone to sublimate into gas, leaving potential pits and crevasses. As a counterpoint is the Cthulhu Macula, perhaps the darkest feature on Pluto. It lies to the west of Sputnik Planum, and this whale-shaped landscape is covered in craters, leading scientists to suspect that this terrain is much older than the adjacent plains. Scientists are still working out how this part of Pluto is colored like it is. There is a theory it has to do with interactions between Pluto's surface and the atmosphere, but more research is needed before an official determination is made. Another location worth checking out on the eastern edge while we're here are Pluto's dunes. Unlike the dunes we find on Earth, these aren't made of sand, but methane. These dunes are a clue to another incredible feature of Pluto, its atmosphere. Pluto's atmosphere may not always be constant, but when it is in place, there's enough energy in it to generate winds. And they can get up to speeds of about 20 miles per hour, which is enough power to form these dunes. Another amazing feature found on this world is its bladed terrain. These jagged ridges stand on Pluto's higher terrain and are absolutely massive, comparable to skyscrapers here on Earth. These icy formations aren't made of ice, though, but, like the dunes, methane, and they have gotten their amazing shapes through sublimation, when ice transforms directly to gas, spurred on by Pluto's changing climate. When it comes to all things elevation, Pluto pretty much has it all. hills, ridges, and of course mountains. There are 11 named mountain ranges on this world. 5 of them are found on the western side of the Tombaugh Regio, including our final destination. But before we get there, we're going to travel towards the South Pole to check out a few of this planet's special peaks. Way down here in the southern hemisphere, you'll find Wright and Picard Mons. These peaks aren't the tallest mountains Pluto has to offer, but they are unique, not only on this world, but in our solar system. They're possibly the most distant cryovolcanoes yet discovered in our local cosmic neighborhood. In some ways, they're similar to the massive shield volcanoes we find on Hawaii. In other ways, they are vastly different. These peaks may not be in the running for highest point on Pluto, but they are definitely not lacking in size or height. Picard Mons comes in with a respectable elevation of 13,000 feet, and Wright Mons comes in at 19,500 feet, and both of them have diameters up to 60 miles. What makes these peaks fascinating to scientists, though, is the center depressions. They don't seem to be like traditional calderas. They are also quite deep, estimated to be as deep as the mountains are high. How these suspected cryovolcanoes erupt, or even if they do erupt, is still being determined. Getting to the top of these cryovolcanoes is not going to be a walk in the park. The landscape surrounding them has been described. Getting to the top of these 2 cryovolcanoes is not exactly going to be a walk in the park. The landscape surrounding them is unique to Pluto and has been described as bumpy, boulder-strewn hummocks. You may wish to think of this ascent as a series of never-ending false summits. Once you reach the top, though, you'll be able to peer into the center depression and take in a terrain that may be unlike anything else in our solar system. When you're finished here, it'll be time to head back north to our final destination. In the southwest of Sputnik Planum, you will find Pluto's highest range, the Tenzing Montes, named after Tenzing Norgay, the famous Sherpa who accompanied Edmund Hillary on the first successful ascent and safe return of Mount Everest. One of the things you'll notice about these peaks is they are snow-capped, but it's not like anything we have seen on Earth. The snow here is pure frozen methane. Perhaps a better description would be red-capped mountains due to its color. Even stranger is these caps form in the opposite fashion a snow cap would form here on Earth. A simple way to explain this is understanding that the higher up you go in Earth's atmosphere, the colder it gets. So when moisture goes up, it condenses, and when it hits a high enough peak, it comes down as precipitation, boom, snow-capped peak. On Pluto, things are a little bit different because it's actually colder on the surface than it is at elevation. So as the methane rises, it becomes more gaseous. But if it does hit a high enough mountain peak, that difference in temperature condenses the methane back into a solid state, and presto, methane-capped mountain. This isn't the only odd thing about these peaks. How they formed is a mystery as well. They appear to be tectonic creations, similar to block and fold type mountains on Earth. But it may be a type of tectonic activity we haven't encountered before. These mountains appear to be very young from a geological standpoint, only about 100 million years old. And that's another point in favor of the theory that perhaps Pluto is still geologically active. Now, the makeup of these mountains is actually something we've seen before, but never quite to this height. These are ice mountains, quite literally. Their main building block is water ice. There are several peaks in the Tenzing Montes, but the one we are most interested in is the one designated T2. You'll have to put in some work to ascend this peak. In addition to being the tallest mountain on this world, it is also the steepest, with slopes 40 degrees or greater. Once you reach the top, you'll have a spectacular view of the Plutonian landscape. You'll be able to take in both the light and dark of Pluto, the Cthulhu Macula on one side and the Sputnik Planum on the other. To the north, you'll spy the Hillary Montes and other ranges beyond. Standing on top of T2 will put you at the highest point currently found on Pluto, with an elevation of 20,341 feet, just a bit higher than you would be if you were on Denali here on Earth. As you look up, you will see the moon Charon filling the sky, and it's going to be an amazing sight and a fitting capstone to our Plutonian adventure. While we may be at the end of our journey outward, we are not at the edge of our solar system. Far from it. Over the course of the last 100 years, our solar system has grown exponentially. Areas that were once theorized have become very real, and new discoveries are being made all the time. The Kuiper Belt is the current known frontier of our solar system, yielding new discoveries on a regular basis. It's made of the remnants and debris from the beginning of our solar system and spans a distance of at least 2 billion miles. It was first theorized by Gerard Kuiper in 1951. Interestingly enough, Kuiper believes such a structure would have been swept away by planetary gravitational influences. Theory turned to reality 40 years later, with the discovery of a tiny object named Albion. Officially, the IAU only recognizes 3 Kuiper Belt objects in addition to Pluto, and that's Eris, Haumea, and Makemake. But there are tons of candidates waiting to join their ranks. Over 1,200 objects have been spotted out in the Kuiper Belt, with more being found all the time. Places like Orcus, Sedna, Gong, Quahar, just to name a few. What we do know of these places is enough to inspire the imagination. But like Pluto was before New Horizons, little detail can be gained from these distant, tiny worlds. The question you have to ask, though, is could any of these objects we've discovered out in the Kuiper Belt actually have the highest point in our solar system? Well, that depends. They're working with the building blocks that we've seen on places like Pluto and Charon in the form of water, ice, methane, or nitrogen, then most likely the answer is no. But as we've seen throughout our solar system, there's always a chance for an exception. There is potentially another mystery out here, Planet X, and the hunt for it still lives on. There is mathematical evidence suggesting there is another sizable celestial body in our distant solar system. The search has been going on for several decades, and there's a variety of theories of what this could be. One was that it was a brown dwarf star named Nemesis. Another was this is a rogue planet caught by our sun. Then there's a thought that maybe this is the mysterious 5th gas giant that was not quite flung out of our solar system when Jupiter and Saturn shifted to their current orbits. And then there's a theory that it could be a black hole. If it is a gas giant, then going by what we have observed in our solar system and among other exoplanets, a body that size would probably have moons, so there'd be additional high points to discover. This planet would be so far out, though, that we'd measure the orbit not in years, but millennia. But our solar system stretches even further. Voyager 2, that old stalwart, continues to race into the great beyond, and it continues to send data back to Earth. Now we're 14 billion miles away on what our solar system looks like out there. Then there's the theorized Oort cloud, a hypothetical construct that truly is a Here There Be Dragons part of our solar system map. The evidence that we have that it exists takes the form of long-travel comets. I mean, they have to come from somewhere, right? Our journey outward, though, stops here in the Kuiper belt. But our solar system adventure is not quite complete. As you may have noticed, our main list of highest points in the solar system is still incomplete. We've got to backtrack a bit and head to our final destination. I'm Skye Marthaler. Thanks for joining me in our travels through the Kuiper belt on Rooftops of the solar system. If you've enjoyed this episode, take a moment, leave a comment below, and click those like and subscribe buttons. And I'll see you soon.